welcome to the video notes for lesson 9-6, congruent figures. This begins on page 42 in your notes packet, and this is the last lesson for this topic. Let's take a look at the learning target for this lesson. I can prove a figure is congruent to another figure using a sequence of rigid motions. Remember what a sequence of rigid motions means? We are doing more than one. So let's write that down. More than one. Okay, so we have an example to look at on page 42 and talk about which image is congruent to triangle A. So we're looking to see if any of these images are congruent. And remember what congruent means: same shape, same size, basically. So when I look at this, the image that has just a single eye in the middle, I can tell just by looking at it that there's something different about this triangle compared to the original triangle A. How would I get from this point to this point? It doesn't look like a reflection. It doesn't look like a rotation. It looks like a translation. But I'm going to put a question mark, and I want you to write this down, translation, because I'm not sure if it really is. So translation is a slide. You're going to move left or right, up or down. So when I count the spaces, let's see, it's 9 spaces to the left and 1 space down. And if I do the same thing for this point, 9 spaces to the left and 1 space down. So far, so good. But then when I use this point, it's 10 spaces to the left and 2 down. This point and this point don't match up. So, is it a translation? Absolutely not. So we'll put wrong. Okay, let me switch up the color here. Now I'm going to use blue. Looking at the image with 2 eyes, and I'm trying to figure out, okay, how did this get over here? And it looks like it's a turn, like it's a rotation. And if it rotated 180 degrees, which it looks like it might have, then the XY would become the opposite of the original point, so it'd be -x, -y. So if I start at 4, 4, this point here and this point here match up. If I start here, this point here and this point here match up. But this point and this point do not. So let me write down, is it a rotation? And the answer is no, it is not. This one is wrong. So this figure, so the first image and the second image are not congruent. So let's look at the third image. And at first, it looks like it may be a reflection. So reflection, question mark. Now a reflection is, each point needs to be the same distance. It looks like it's reflecting over the x-axis. Well, let's see. So this is 1, 2, 3, 4. 1, 2, 3, 4. These match up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These match up. But then when I see how far this point is, it is further. This point is further away from the line of reflection than this point. So it is also not. The reflection doesn't work either. So the answer to the question, which image is congruent to triangle A? None of them are. And that's because none of these are the same shape and the same size. And I bet most of you could probably tell at least the first and the third. The second one looks pretty close, but I think if you look at it long enough, you can tell the second one and the original image are not congruent to each other. All right, so what was the purpose of that? Well, it was basically to show you how you would investigate to find out what motion, what transformation is happening. So let's take a look at page 43, and we're going to have a couple of examples that do work. So, key concept, a two-dimensional figure is congruent to another two-dimensional figure, and that's a really big idea. So I better underline. Is congruent to another two-dimensional figure if you can map one figure to the other by a sequence of rotations, reflections, and translations. The symbol equal sign with a mustache means is congruent to. And remember, congruent, same shape, same size. Now, when I look at point A, I'm going to write the coordinates. It's 4, 4. When I look at, so here's my original. Here's my image. Point A prime is at -1, 2. Now, one of the first things I focus on is the orientation. So if I look at triangle ABC, its orientation is clockwise. When I look at the image, A prime, B prime, C prime, it has a counterclockwise orientation. So I know right away I'm going to need some type of reflection. Now, if the orientation is the same, that can happen if you have more than one reflection. But oftentimes, if you have the orientation different, you know that you have a reflection. So I'm going to say the first thing that was done here is a reflection. Now, what did it reflect over? Well, it looks like it reflected over the y-axis. So reflection across y-axis. And what happens when you reflect across the y-axis? Well, the point you started with, xy, becomes, remember, the y-axis means the y value stayed the same, and the x-coordinate, the x value, becomes the opposite. So in this case, 4 became -4. So I'm looking at being right here, the point -4, 4. Now how do I go from -4, 4 to 1, 2? Well, -1, 2. Well, it's not going to be a rotation, it's not going to be another reflection, so the only other option would be a translation, a slide. And when we did the translation, it looks like it's going to the right 3. So the point's right here, it's going to go right 3 spaces and down 2. And I can write that rule, nice and simple. So my point is xy. To go to the right 3 means I add 3 to x. And to go down 2 means I subtract 2 from y. And that's how you would get from this original image to, or excuse me, the original figure to the image. You reflect over the y-axis, so you take all your points and do -x or opposite of x, y. And then you translate it to the right 3, down 2. So all your points are going to add 3, subtract 2. Okay, let's put this all together in the examples below. Okay, given. So given means they're telling you this is true. Triangle QRS is congruent to triangle Q prime, R prime, S prime. So here's my original. Actually, let me use a different color. Make it easy to see. Blue works. Here's my original. Describe a sequence of rigid motions that maps QRS to Q prime, R prime, S prime. So, I am looking, the first thing I always look at is the orientation. So QRS goes clockwise. When I look at Q prime, R prime, S prime, it goes counterclockwise. Because the orientation has changed, I know I am going to need a reflection. Now, if the orientation is the same, that means there's either no reflection or there's two reflections. But in this case, we know for a fact that there's going to be a reflection for it to be changed. Now, let's go ahead and do the reflection first. And you can probably tell, well, if I reflect over the x-axis, it's going to kind of, it's not going to be pretty. So I think we'll reflect over the y-axis, because if you reflect over the y-axis, your image, so R is going to reflect over to here, and Q is going to reflect over to here, and S is going to reflect over to here, and you've got this first transformation here. And it looks pretty clear now that you're going to be able to get from here to here relatively easy for step 2. So first step, reflection across y-axis. Remember, let's write the rule. The rule is you start at point xy, and when you reflect over the y-axis, y stays the same, x becomes the opposite. So this point here, which is -2, +4, the y stays the same, +4, but the -2 becomes a +2, so now it's 2, +4. And then the second transformation that happens is a translation. Clearly it's not going to reflect again. It's not going to rotate. It is going to translate, and it's just going to do one move, and that's down 6. So translation down 6 spaces. And the rule is, so now our new points, x and y, are going to, the x value stays the same, because that isn't affected by going up or down. But the y values are going down 6. Something else you should know is, for this sequence of motions, you can do them in any order. So you could have gone down 6 first and then did the reflection, or did the reflection and then down 6. That isn't always true, but it is true for many of these examples we'll be looking at. Okay, the next one, I'm going to get you started on it, but I'm going to have you finish this. So, first thing I want to recognize, again, they are giving us or telling us that ABCD, rectangle ABCD, is congruent to A prime, B prime, C prime, D prime. So, and we know it's going to be 2 rigid motions. So we got to figure out what are those 2 motions. Alright, so there's going to be 2. And looking at it, here's the original right here, and here's the image, and that's going to be the second transformation that gets us there. So when I look, it goes A, B, C. The orientation goes this way, which is clockwise. So A prime, B prime, C prime, D prime goes clockwise also. So because the orientation is the same, that means it's either 2 reflections or no reflections. So just really quickly, if I reflect, let's say over the x-axis, A goes up to here, and then if I reflect over the y, A goes over to here. Well, that's not going to work. So that means there are no reflections. So everybody write that down, because the orientation is the same. So, what are the two transformations? Well, I am going to tell you what they are, sort of. I'm going to tell you the first one is going to be to rotate. Remember, when you rotate, you always rotate counterclockwise. So you're going to rotate, and then you are going to translate. So what I want you to do on your own is figure out how many degrees you're going to rotate, and figure out how many spaces you're going to translate. So see if you can come up with a rotation and a translation that gets A, B, C, D to A prime, B prime, C prime, D prime. If you don't know, guess. Just try to guess something. Alright? So that's it for this video. I know it went a little bit long, but this is a real big idea, although I think those of you that have been practicing will really understand this and have no trouble at all. That's it for this. If you had any trouble, go back and rewatch the video. Good luck, and we'll see you in math.